We will examine the Su-57 fighter jet in this video. The foundations of the Su-57 project are based on the PAKFA program, which began in the late 1990s. The aircraft made its first flight on January 29, 2010. Preparations for serial production emerged around 2019, and the Russian Ministry of Defense announced that it had accepted the first production aircraft and commissioned them as of 2020. However, due to low production numbers, testing phases, and ongoing development efforts, the procurement process progressed slowly. It has been reported that only a limited number of deliveries were made annually between 2023 and 2025. Prominent features of the Su-57. The Su-57 is a highly impressive fighter aircraft from an engineering standpoint. Even the numerical data demonstrates how comprehensive its design is. At approximately 20 meters in length, it is a large fighter aircraft. Its wide wing structure provides an aggressive aerodynamic profile. Its fuel capacity is quite high, over 10,000 kilograms. This enables both long range and a greater ability to carry weapons internally for enhanced stealth. It is twin-engined, and each engine produces strong thrust in both dry and afterburner modes. The AL-41F1 engine can generate approximately 142 kilopascals of thrust with afterburner, and this value may increase slightly in emergency situations. It has a supercruise capability, meaning it can fly at high speed without continuous afterburner use. This offers both fuel efficiency and tactical advantage. Its maximum speed is around Mach 2. Its climb performance is high, and it is reported to maneuver up to +9 G. Its range is about 3,500 kilometers at subsonic speed and around 1,500 kilometers during supersonic flight. Its weapon capacity is quite high. It has 12 weapon stations. Internal bays provide stealth advantages, while external stations increase payload capacity. Its total payload is reported as approximately 10,000 kilograms. Core technological features: airframe and stealth. The Su-57 features a structure designed for low radar cross-section, RCS, and radar-absorbing coatings. However, instead of adopting the full invisibility concept used in US models like the F-22 and F-35, the Russian design follows a different strategy focused on reducing visibility at certain angles and radar frequencies. Sensors and avionics. It carries a primary AESA radar, such as the N036 Bielka, in the nose. Additional radar arrays integrated into the fuselage and sides provide advanced sensor fusion, target detection, and electronic support capabilities. It is also designed for network-centric warfare, offering tactical data sharing and system-level integration. Engine and performance. Early prototypes and initial production units used AL-41F1 engines. The long-term target engine is the more efficient and powerful Izdeliye 30. The Su-57 can reach about Mach 2, and with 3D thrust vectoring, demonstrates a high degree of supermaneuverability. Weapon systems. The aircraft features internal weapon bays, allowing weapons to be carried without protruding from the fuselage, reducing radar visibility. Both air-to-air and air-to-ground munitions can be carried internally. External hardpoints can be used when necessary, although at the cost of reduced stealth. Differences from other aircraft: maneuverability and kinematics. Thanks to thrust vectoring and its aerodynamic shape, the Su-57 offers high maneuverability even at low speeds. In this respect, it differs from aircraft such as the F-35, which rely more on sensor superiority. Stealth approach. While U.S. aircraft aim for broadband low observability, the Su-57 focuses more on low observability at specific angles and frequencies, combined with strong electronic warfare capabilities. As a result, the F-22 and F-35 are generally accepted as having superior stealth, while the Su-57 offers a strong combination of speed, maneuverability, and payload capacity. Network and UAV integration. One of the program's major goals is for the Su-57 to operate cooperatively with unmanned aerial vehicles, e.g. the S-70 Okhotnik. This would make it a network node in future combat doctrines. Maturity and production. Unlike the widely produced and extensively deployed F-22 and F-35, the Su-57 is still being produced produced in limited numbers. Sanctions and supply chain issues have reportedly caused delays in some systems. Costs. The unit price of the Su-57 has not been officially disclosed. Estimates vary widely, but the estimated unit cost ranges between $40 million and $120 million US. Actual cost depends on configuration, advanced sensor packages, and engine type. Information on operational costs is limited, although fifth-generation jets generally have high maintenance expenses. Reports of some Su-57 units being delivered with incomplete sensor packages indicate that costs may rise over time. Operational status. The Su-57 has entered service with the Russian Air Force in limited numbers. Some units are used for training and tactical development. It has reportedly conducted test missions in conflict zones on a limited basis. Although scaling up production and export options are under discussion, sanctions and concerns over technology sharing present significant challenges.